Hi, it's Mrs. Moss here, and now we're going to continue talking about the different ways that we can identify minerals. So far, we learned about using the streak test, using the Mohs hardness scale, and other ways that we can classify and name minerals. Well, today we're going to get right into it and start talking about the last specific way that we can identify a mineral, and that is by its crystal structure. The outward geometric shape of a mineral is due to the internal arrangement of atoms. Let me show you what I mean. This picture on the left-hand side shows the atomic structure of galena. And if you look at the picture on the right, if my face isn't in the way, you will be able to see galena's actual outward appearance. It looks to be like cubes, just like the picture on the left. Here are some other common geometric shapes of common crystals. Galena, as we said, was cubical. Quartz, zircon has that pyramid shape. Sulfur, hornblende, and albite. Again, might be under my face. Sorry about that. Here's some more pictures of the geometric shapes that minerals can take on. Again, all due to the internal arrangement of atoms. So there are another cool picture that's really neat. You can see the geometric shape. Okay. There are some special properties that certain minerals have over others. We're going to talk about that rather quickly. This goes in the bulleted section of your notes. Density. Any single mineral will have a fixed density. For example, gold will always have a density of 11.3 grams per centimeters cube. The density never changes regardless of the size, shape, and mass of the sample or the mineral. And here's a picture of gold in a gold bar, whereas that gold medallion always has the same density. Some minerals have magnetism. For example, the mineral magnetite. It will actually attract metal objects. Other minerals have optical properties, where you would see an optical illusion just by looking through the mineral. For example, if you look at this flower stem, it looks almost double when you put a block of mineral over it. Calcite creates that image, that double refraction. Let me show you another picture. Here we have a nail or a sewing needle, and when you put the block of calcite in front of it, it almost looks as if there are two needles behind there, where it's only one. Just an optical illusion. Another way we can determine a mineral's identity, some minerals will actually fizz when it comes in contact with hydrochloric acid. Again, the mineral calcite will do this. We will not be using acid in our practice at school. Fluorescence is yet another special feature that certain minerals have, and it will glow under ultraviolet light or black light. Other minerals are radioactive, and so they have subatomic particles that are released, and it's measured with a Geiger counter. Taste. Some minerals have a salty taste, and they can be identified by using your taste, your sense of taste, but we're not going to be doing that in school either. There are some native elements that are also minerals. They are composed of a single element. For example, gold, copper, silver, and platinum, and sulfur. I'll just show you a few pictures of these single elements that are actually minerals. Gold. This is a picture of platinum, which is a white gold. Here's a picture of the periodic table of elements, and it just shows that some of those are on there. Okay, sulfur. Okay, this brings us to the properties of common minerals reference table. Now this is a very important page on your reference table. It's actually on the back cover, and I'd like you to take that out right now. You should hit pause and go and get your reference table. Okay, now that you have your reference table, let's go through this. All of the characteristics that we just took notes on are on this back cover. So it's a nice thing to use where you don't need to memorize anything. Let's start with the mineral's luster. If you look, we have metallic and non-metallic. Okay, it goes along the side left column. So all of the minerals that we're going to be looking at that have a metallic luster will be located in this upper part of the reference table. Anything with a non-metallic luster, we look automatically down at the bottom. Hardness comes next, and that's using the Mohs hardness scale. It will help us to determine what the mineral's hardness is. And so we look at that, excuse me, let me go back. We look at this column right here to determine that. Now notice it goes from 1 to 6 with the metallic luster, and then once you get into the non-metallic luster, it starts over again at 1, and it goes all the way up to a hardness of 7. The next column is cleavage or fracture, and you can think of it more like a checklist. If it's on the left side checked, then it has cleavage. If it's on the right side checked, then moving on. Next to cleavage and fracture, we have the common colors, which we did say was the least reliable way of identifying minerals. And we have the distinguishing characteristics of a mineral, which are some of the tests that I told you about, the streak test. The streak color will be listed in this category. The cleavage and the way it breaks, whether or not it can bubble with acid, those type of distinguishing characteristics are found in this column. We also have common uses, which are just ways that we can see minerals being used in everyday life and how it applies to us. If you continue over, we have the mineral name, and that will allow you to determine what mineral it is. And then the last column is the chemical composition. Now the chemical composition is composed of symbols that make up this element. What chemical symbols make up the mineral. If you're not sure of what those symbols are, if you look at the bottom of the chart, you see their key, tells you exactly which elements it is. Okay? So this is it for the science reference table, and this ends our discussion of minerals. We're going to be practicing more with minerals in class over the next few days and before we move into rocks. Okay, thank you so much. Again, go back, take notes if you missed anything. Otherwise, we'll see you tomorrow.